LIME is a popular tool for interpretable AI that gives local explanations. Let's see how this works. A popular approach in interpretable AI is to approximate more complex models that we need for our tasks with simpler models in order to explain them. For instance, you could build a deep learning model to adequately capture all the complexities in your problem, but then you can build like a linear regression or a decision tree model to explain it. It could take the same input features as your original model, but the target for this simpler model will just be the predictions from your black box. So one challenge with this approach is that if you make a global model, for instance, if I use least squares on this data here, I see that it's doing an okay job but not a great job because there are many points here in this curve that are very far from the straight line. And if I want to explain a data point that lies here on the curve which is far from this line, then my interpretable model will probably do a bad job of it. So let's take this example here. So the whole idea is, can we actually come up with more local explanations that are more suited for a particular data point? So if I take this data point A, instead of fitting a global straight line with some kind of a slope, like 30-degree slope that we saw in the previous picture, it would make more sense to fit an almost vertical line at A and an almost horizontal line at B, which would better explain those data points. So I know that at point A, the y coordinate is important and the x coordinate is hardly changing, while at point B, the x coordinate is rapidly changing, but the y coordinate is hardly important. And that's my local explanation that I can get, which makes more sense for these points. So LIME is a model to give local explanations, and it stands for Local Interpretable Model Agnostic Explanations, and it can be used to interpret or explain a specific outcome for a specific data point. So how does it work? So how do you get this local fit? The idea is, for each point, let's give more importance to the neighborhood around that point. And the way that's done is through weighted least squares with respect to that particular data point. Weighted least squares just means that the nearby points have more weight. So the standard least squares will fit a straight line like this through a bunch of points. But when you do weighted least squares, it looks at what data point you're interested in. So this is our query, suppose. So it's somewhere here. So the points around this query point, so in this neighborhood, I probably want to give more importance. And then if I only consider this local neighborhood, I end up getting, a line with a different slope. Along with the least square regression, it also uses a regularizer typically, like lasso, which limits the number of features to understand the top features for each specific prediction. Now you can replace this regularizer and the actual least squares model with something else and use the same framework though. So the framework for LIME is as follows. First, we select an instance where we want explanation. This is the point of interest. And then we select a neighborhood, which are the points close to this point, and then get a perturbed version of these points by adding some noise. Now we have a small neighborhood data set. We fit a black box model and obtain predictions for these points to get target labels for these data points. Now we fit locally weighted model with the appropriate regularizer, and then we interpret the parameters of the local model for explanation. So LIME is very easy to use because you have a Python library that can be, you can just do pip install LIME, and you can actually see documentation for LIME. I have given the link here where you can go and see some examples for LIME. So you can give it some inputs such as the training data and the feature names and so on, so that it can give you a nice visualization. And when you want it to explain a specific instance, you can actually call explain instance to give you your point of interest for which you need an explanation of the outcome. And then you can give the number of features that you care about. In this case, the top 2 features. And also often you can specify the kernel width, which is specifying how much of the neighborhood around that point you wanted to consider when you give the local explanation. So when you look at the explanation here, you can see that there are three classes, and it's showing that the class is setosa for this data point, and the explanation is here that these are the two features that actually led to this particular prediction, that the class is setosa, and what is the weight for each of these features is something you can see here. And you can get different kinds of visualizations. It has like a few other options the way you can show this visualization. And you can look at more information about LIME by looking at the documentation. Some problems with LIME include selecting the kernel width or the size of the neighborhood is sometimes tricky. So the same neighborhood size does not fit all situations usually, and it requires some careful tuning. And another issue is that of stability, where small perturbations can sometimes lead to different explanations. If you recall, we perturb the neighborhood to get training data for our local explainer. So different perturbations lead to different explanations, and this could be an issue with LIME. But all said and done, LIME is one of the easier tools that you can directly do like a pip install and start using to get local explanations for specific outcomes from your model. To summarize, we looked at LIME, which is a model for interpretable AI to give local explanations. It uses something like weighted least squares with a lasso regularizer to locally fit around a specific data point, a simple model, and based on that, give explanations such as what are the features that are leading, top features that are leading to a particular prediction. Thank you.